Hello, hope you're all doing great. Welcome to the driving behavior analysis presentation. So without further ado, let's get started. So the purpose, the reason why we selected this unique topic. Well, let me first of all explain to you what it does and how it can be important to everyone else. So the purpose of this paper was to basically find out the best approach we can use to detect driving behavior patterns of a driver by collecting different types of data. So for the scope of this paper, in regards to that, the only data that we are capturing will be speed. We can further in the future add more aspects to this as well. Moving to importance, well, I believe that this data can be really useful for machine learning. As we all know that machine learning models are basically trained on data. So if our data is accurate, the better our machine learning models will be. The best example I can give you is of Tesla. Now, for those of you who don't know what Tesla is a company that basically builds automotive vehicles. And these vehicles basically have a central hub. They all share one central hub through which they communicate and through which their models are trained. So if an incident happens for one vehicle, that is sent back to the hub, and every other vehicle connected to that hub is updated regarding that and how to better tackle that if they face it. So imagine if the data that is sent to the hub is corrupted. That would just send out false information or data to everyone else, causing putting so many lives in harm's way and sending out this misinformation. Secondly, and that alone shows how important of the accurate data is for such machine learning models. Secondly, as we all know, speed directly corresponds to fuel in a way that we can control our fuel based on the speed that we have. So if we can control the speed, we can control the fuel consumption, because as you know that there is a specific speed limit where each vehicle can sustain its fuel consumption. Now this can be really important for other fleets that are using automotive vehicles to ship cargoes from one place to another, where they can just set a specific speed limit and their vehicles will simply try not to like break that speed limit, and hence resulting in an efficient fuel consumption. Apart from this, the data that is obtained through these experiments is really real time, so we can monitor this vehicle of our speeds as well. And like mentioned above, this will act as as an enhancement and will open new doors to self-driving vehicles. Experiments. Now, basically, there were three different types of experiments that were conducted with different technologies. One of them is a GPS approach. The second one is an accelerometer, and the third one is the OBD approach. So here I will just give you an overview what each of these were doing. We can go into more detail in the later sections. So the GPS approach basically takes a starting point and an ending point of a trip, and it measures two things: the distance between these 2 points and the time it takes to cover this trip. From these two values that we get, we can calculate our speed. Moving to accelerometer, basically since this is a sensor, there isn't any calculation required. It basically just feeds off raw data to us. But we will see that there is a drawback to this approach in the next slides. And finally, the OBD approach, where an onboard diagnostic system is integrated with the vehicle's engine control unit and sends data to our smartphone. For the purpose of our experiment, we selected a smartphone. Of course, this can be replaced by other devices as well. Moving towards the GPS experiment, we actually did not opt for this approach because of a few factors that play a crucial role in this. One of them was that it was massively influenced by factors that are not in our control, such as tunnels, solar storms, satellites, and all of those. Apart from that, at certain time it was down to a probability. Now, this point was actually researched by the United States of government, uh, where they basically ran an experiment and a research and found out that the value that or the data that is being shown by the GPS cannot be used for such experiments, because it was down to probability, meaning that it could be wrong at some of the times. And from the picture below, you can see that the GPS approach does not incorporate any changes that are made to the data between these 2 points. And as the image specifies that from point A to point B, you will only get the data between these two. And if a point C, an obstacle at point C occurs where the driving speed is reduced, or if the vehicle is stopped, or any change to the data occurs at point C, that will not be detected by the GPS because it does not validate that to a point where it incorporates it into its process. And lastly, the data was exceedingly unreliable when the path was elevated. It could be steep, it could be, it could be a slopey path or anything like that. Because with GPS, it will always be a straight line, whether it's incline or whether it's decline. So overall, the data we obtained from this experiment was a fraction of the real data. The GPS technology was basically not simple, was not simply made for this type of calculation or this type of data gathering. Moving to the accelerometer experiment, and we also did not opt for this approach as well because of a few different factors. One of them was that, as you all know, basically an accelerometer measures force on 3 different axes, x, y, and z. And at any given time, gravity will always have an influence on it, whichever axis is pointing towards that, to the direction of the Earth or the gravitational pull. And the second most important factor was that for a successful experiment to be performed, all 3 axes must be synced together. Like from the image, you can see that the red X, which we can say is y-axis, needs to be pointed the same direction where the vehicle is. And the third problem with this approach was that, as we all know, that the vehicle itself produces vibration through engine and all the other internal components, and those vibrations were forcing out invalid and inaccurate values from the accelerometer. Now, we did find a way where we can reduce this by using a gyroscope. Basically, we use the gyroscope's angular rotational movements to make it a little stable, but then again, the complexity of the results that we were getting after that were really not comparable to speed. So overall, the key challenges in this experiment was keeping the axis synced, but the vehicle vibration was unavoidable in any case. And in case of the gyroscope angular rotational movement, it was near impossible to sync with accelerometer readings as well. And why is the accelerometer readings not mentioned here? Well, the reason for that is, like I mentioned above, the accelerometer reads readings in 3 different axes. So at that point, if we compare a constant value that was provided by the GPS to something like that, it would be similar to comparing apples and oranges. It just wouldn't fit together. So finally, the conclusion that we arrived was that the OBD was the best approach for detecting such information or data, and other technologies are just not trustworthy for such analysis. Now, there are 2 questions that we can ask here. How can this benefit the field of IT? Well, I believe that this will play a crucial role in self-driving vehicles. It is a really good step forward towards machine learning models, especially if they are involved in automotive vehicles, um, self-driving automotive vehicles. And apart from that, we can monitor our fleets with real time with this data, and we can this sensor is compatible with numerous other sensors apart from the ones that the vehicle is integrated with already. And the second question is how this can be a path forward for humanity. Well, there are 2 points that I mentioned here, which we can say that if you follow something like this, it will happen. Number one is that it has the capability to reduce the fuel consumption. which is, as you know, massively affecting our environment as well, because the carbon emissions from vehicles is responsible for 90% of the global warming that has been going on these days. And secondly, decision makings to avoid accidents. Now, as you know, that if a person is put in a position where they are faced with a situation where they need to make a really crucial decisions, human emotions run through us, and they can cloud our judgments or delay them. Both of them can be very, very vital in defining what happens to that person. But for a system, it is either just yes or no. And I believe that if we used this data, which Tesla already is using something similar, and it has saved numerous lives through this, I believe that this can further enhance that. And this is it for this presentation. I hope I covered all of the things that would give you an understanding what the purpose was, what the experiments were, what was the difference between them, what the results we got, and what the conclusion is. Thank you for your time.